All right, Patrick Cook here. Uh, Thanks for coming back to the next session. We're in the process of talking about lighting in the Mandelbulb 3D animation project that we're working on. And where we left off in the last session, I was talking about the ambient light, and I was saying that you want your ambient control to give you a good balance of lighting across the whole scene, and you want your depth control to give you a good balance of how much ambient light gets into the shadow area so that you can maximize the visibility of the detail within the shadow area. So you'll find that, I guess especially with a three-dimensional fractal uh, artistic environment like this, lighting has a lot to do with how interesting the scene looks. Because with lighting, you're able to do a couple things. Obviously, you can illuminate the features of the fractal object or image or scene. You can illuminate it. You can also create shadowing, or I should say, manage shadowing, so that the various attributes, the patterns uh, of the fractal image are accentuated. And shadows also help provide a sense of depth, a sense of contour, and interesting patterns. You can accentuate patterns with shadows. You can de-emphasize patterns with shadows. You can change the entire characteristic of a pattern by the use of shadowing. So shadowing are very important. Shadowing is an it's an attribute of light, and you want to use shadows as skillfully as you use light in the Mandelbulb 3D environment, and that would be true with many different uh, visual graphic pursuits. Shadows are quite important. So now let's turn our attention now to dynamic fog. That's over here on this tab. Now, the dynamic fog is can be supercritical to your scene. Basically, what this defog, this dynamic fog, does is it will it will um, it will try to simulate the natural nature environment where you have moisture or particulates or smoke, or whatever you want to call it, but typically it's moisture, where the air is laden with moisture that will then reduce the amount of light that makes it through your your moist air. So it's trying to simulate. These controls are attempting to simulate the behavior of light through air that has moisture, that it either depletes or reduces the intensity of the light, or refracts it, or uh, fog moisture doesn't normally reflect it. It doesn't normally reflect. It might diffract a little bit, slightly change its angle, but typically fog will reduce the intensity of light. So the reduction of the intensity of light in the scene can be quite interesting. Now, well, let me show you. So on the dynamic fog, um, you've got two different kinds of fogs. You know, you've got the volumetric. That's more advanced. We're not going to talk about that right now. And that volumetric fog light is very, very uh, computer intensive. But I don't want to go down that path right now. That's something for in the future. I want to talk about your normal dynamic fog. So I have the dyne fog here, and I have a control, and I'm able to dial this up. All right, now effectively what I've done there is I have introduced so much fog that the light has dissipated, the light source has dissipated so severely that this is what I get. Normally you don't want that. All right, now here I have reduced the setting of the fog, which means basically I have no fog at all, which means that I have no no reduction of light. It's just boom. All right. So now here is midpoint. I'll just keep it right here. Let's go to this fog offset. And then there's the far offset. All right. Now the fog offset is basically how close the fog is to the camera. Now remember now, early session, I talked about you are the camera. All right. There is no top down, left or right view. Everything that you see in that scene is you. You can only look through the camera. So the fog offset is how close the fog is to the camera. All right. So if I'm like way right there, the fog is like really close to the camera. If I put the control out here, the fog is way out, way out. All right, so again, you're looking for a decent balance between where that fog begins relative to the camera. Now, the far offset is how far out the fog will go before it stops. Uh, you know, the software by design does not create something out to infinity. There's a limit to how much the code can process before it says, look, the programmer says, look, I got to stop processing because I can't keep doing this to infinity. I've got to get my, I've got to let the computer CPU do something else. So the far offset is how far out the fog will be before it stops, when it stops making fog, or simulating fog, I should say. All right. Now, here's the fun part. All right. Your job is to find a way to get a really good balance between all of these three fog controls. All right. I'm tweaking it around so you can kind of see. I want a good balance between all these fog controls. I mean, you look right in here. All right. This, let's see. Watch right in here as I adjust the fog, the far offset. You see how that went white? Because the program got to a point where it didn't create fog anymore. It didn't simulate fog anymore. Now I'll dial that back down. Okay, so there we go. So now it's the far offset is closer. The far offset is further away. All right, and then my fog offset is how close it is to the camera, is very close. I'm sorry, very close here, far away there. All right, and then here's my dynamic fog. See that? Now you got to, okay, I've increased the fog. I've increased the fog density. This is the density, okay? And I'm really close to the camera. There you go. Excuse me. So I have maximum density, maximum closeness. I can't see anything. Well, that simulates a real world. All right. All right. So we're out of time on this session. We'll pick it up again in the next session. I'll see you there.